Okay, welcome to Molar mass conversions with Mr. Schmidt. And so we're just preparing for our pop quiz. So let's go ahead and get started. Okay, so first things first, we're going to look at these acids here. And one thing that we need to pay attention to, man, I'm having issues with the technology. One thing we need to pay attention to is the types of acids that we have. All right, so we have nitric acid. Notice that we have nitric acid, we have nitrous acid, and I put hydronitric acid. And I purposely put something in here that was very similar so that we could kind of see the differences and identify what we need to do here. So one thing you should notice is that one of these is radically different in that it has this prefix hydro. And anytime you see that prefix hydro, that's telling you, so if you see this prefix hydro, that's simply telling you there is no oxygen in your formula. No oxygen in your formula. It also means that it's binary. It means it's going to contain hydrogen and then an element from your periodic table. All right. And it's probably going to be, one of these in this region. Whoops, maybe include those as well. So it's probably going to include one of those, but it's and no oxygen whatsoever. All right. And then if we also look and see the others do not contain a prefix. So if we have no prefix, that means it does have oxygen. It means it's an oxyacid and contains oxygen. All right, so your oxyacids are a little bit different, all right, because there's a little more to that. So what you have there is a rule where you can apply the relationship between ate and ick and ite and us. All right. And so if we look at number one, we're going to see, we're looking over here, these polyatomics polyatomic ions will end in either ate or ite. If your acid ends with an ick, then look for the polyatomic ion ate. If your acid ends in us, look for the polyatomic ion ite. Okay, so our first one, let's call this number one. I think maybe I'll erase my numbers. So we have 1, 2, 3. We have nitrous acid. Notice it's nitrous. So nitrous acid. And so what is the polyatomic that we're going to be looking for? Ite. So we're going to not find nitrous, we're going to find nitrite. And if you go to your polyatomic ion sheet, you'll see that nitrite is NO2. NO2, 1 minus. All right. So that's how we know that this is going to be nitrous acid, because us uses the ite ion. One thing you should also know is that all acids contain hydrogen. All acids contain hydrogen. Acids with the prefix hydro contain hydrogen. Acids without the prefix hydro contain hydrogen. All acids contain hydrogen. All. So you have hydrogen along with the nitrite ion. And you see the sum of the charges equals 0. 1 plus -1 gives you a charge of 0. So you just rewrite that HNO2. And all acids are when they dissolve in water, have hydrogen ions when dissolved in water. And so that's why we put aqueous. Aqueous means dissolved in water. So we now know the formula for nitrous acid is HNO2. All right, and so now we can calculate the molar mass. We have hydrogen, nitrogen, and oxygen. All right, so if we have hydrogen, nitrogen, and oxygen, we just now have to count how many hydrogen do we have in HNO2. And what you should see is we have 1 hydrogen, 1 nitrogen, and 2 oxygen. And now we simply multiply that number by the molar mass found on your periodic table. So if you come over here to your periodic table, you can see hydrogen is 1.0079, and our unit for molar mass is grams per mole. We go over here to nitrogen, and we see that it is 14.007. All right, so we'll write that over here, 14.007. See if we can get that to show up again. All right, 14.007 grams per mole. And then oxygen, find that on your periodic table, is 15.999 grams per mole. And so when you multiply these out, you're going to get 1.0079 grams per mole. You're going to get 14.007 grams per mole. And you're going to get 31.998 grams per mole. So the next thing you got to do is just simply add those up. So it's very important to note that if you don't come up with the right formula, you're definitely not going to get the correct molar mass. So it's very important that you are coming up with the formula HNO2 for nitrous acid in order to get the correct molar mass. Otherwise, you will come up with the wrong answer. And so what you should get there is 47.01 grams per mole. And I'm only going out 2 decimal places. So 0.01 grams per mole. And that's for nitrous acid. Okay, let's look at the next one. So here we have hydronitric acid. So remember when we saw hydro, that meant no oxygen. It means that it's binary. All right, and we also said you're probably going to be mixing that hydrogen with one of these elements right here. And these are the most common that go with the hydro. So if we have hydronitric acid, we're not interested in anything other than this prefix hydro. All acids with the prefix hydro have the ending ic. So that's not an important thing at all. You don't even need to pay attention to the ic. It's not important. Only the prefix hydro. And that prefix hydro tells you there is no oxygen. And so what we look here for is we're looking for the nitride ion. So we see that right here. And I told you it would probably come from this section. So that's nitride. What is the charge? The charge is 3-. And so, and we should also note that all acids contain hydrogen. And so the sum of the charges here do not equal 0. So I'm going to put a 3 here, a 1 here, and I'll rewrite that as H3N, and it's aqueous. All right, and so that's the formula for hydronitric acid. Notice there is no oxygen in that formula. Okay, so now all we have to do is write or calculate the molar mass. So let me rewrite that. H3N AQ. All right, and so when we do this, we just simply, what is in hydronitric acid? Hydrogen and nitrogen. How many hydrogen? 3. How many nitrogen? 1. So we take times the molar mass, And you find this on your periodic table. We just saw that in problem number 1. And you find the molar mass of nitrogen is 14.007. We just pointed that out in number 1. And you multiply these out. And so you should get something like 3.0237 grams per mole. And you should get 14.007 here. And when you add that up, you should get 17.03. And again, I'm only going to do 2 decimal places. Grams per mole. All right. And so that covers the answer for that. So you should be trying these. See if you can't get them on your own. Check your work. If we go to the next one. Oh, maybe I skipped one here. I did skip number 1. I didn't see that. Whoops. Let's just make this, let's renumber this. It's no problem. So we'll call this number 3 now. We didn't get nitric acid. So let's get that. Nitric acid. All right, let's do that one real quick. I guess I left it off. So we go to nitric acid. Notice there is no prefix hydro, and we have the ending ic. And we can see that ic, ate, and ic are related. Ate is related to ic. So we have nitric acid. We're going to find the polyatomic that ends in ate. So we're going to find nitrate. And that is NO3, 1 minus. Remember, all acids have hydrogen, 1 plus, nitrate, 1 minus, and we get HNO3, AQ. All right. So we'll go back up here and calculate that. And I wish I wouldn't have messed up on the order, but it happens. So we have HNO3, and all we simply do is find out what's in nitric acid. Let me see if I can get myself a little more room here. Let's put this up here. HNO3. So you have hydrogen, nitrogen, and oxygen. And you have 1 hydrogen, 1 nitrogen, 3 oxygen. And so you simply multiply this out. You find these from getting on your periodic table. So get that off your periodic table. Nitrogen is 14.007 grams per mole. And then oxygen is 15.999 grams per mole. So you multiply these out, and you get 1.0079 grams per mole. And you'll get 14.007 grams per mole. And you'll get 47.997 grams per mole. So we add all those up. And what you should get is 63.01 grams per mole. And I'm just going to go to 2 decimal places. And so there we are with nitric acid. And if you notice, nitric acid has 1 more oxygen than nitrous acid. All right. And so if you were to take your molar mass of nitric acid and subtract 16, or the mass of 1 oxygen, you'll actually get 47.01. So you can see they're very close. It's just 1 oxygen that separates nitric acid from nitrous acid. All right, and we know that in hydronitric acid, there's no oxygen whatsoever. Okay, so hopefully that helped. Let's go ahead and look at some other problems that will be likely to appear on your pop quiz. So it's very important that you understand your periodic table and understand that your molar masses, all right, and we say calculate the molar mass. When we're saying the molar mass, we're saying the mass of 1 mole. Now, we're looking at compounds a lot, but if we say what is the molar mass of magnesium, and here is magnesium, we're going to say that that is 24.305 grams. So if we see that, we know that this mass in grams, right, 24.305 grams is equal to 1 mole of magnesium, which is equal to 6.02 times 10 to the 23rd atoms. And this number is also called Avogadro's number. So it's very important to know that when we see this mass, it is equal to that many atoms, or that many atoms is called 1 mole, which is also called Avogadro's number. So you need to make sure you understand that concept there, because that's going to play a big role in understanding the full concept. So calculate the molar mass of diphosphorus decachloride. So one thing you need to recognize here is that we have a molecule. And when you have a molecule, it's the only type of compound with prefixes. If you see these prefixes, you do not want to look at charges. You do not need to look at charges. You can't look at the charges. You only look at the prefixes. This di is on the word phosphorus because there are 2 phosphorus, di meaning 2. So that means phosphorus, there's 2 of them. This deca is right on the word chloride. So that deca meaning 10 means there are going to be 10 chloride. So it's P2Cl10. Notice I did not try to come over here and find charges, and you should never see 2 negative charges when you're trying to do this anyway. And a lot of people I see in their work, they're trying to put charges when we have a molecule. When you have a molecule, and you know this because it has these prefixes, do not look at charges. Only write down the number that you see as indicated by the prefix. That is very, 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 very important. Okay, so if you can calculate the molar mass of that, that is the mass of 1 mole. So you simply find what is in the diphosphorus decachloride, and you have phosphorus and you have chlorine. And then you just count, how many do you have? I have 2 phosphorus, 10 chlorine. Multiply by the mass found on your periodic table. So if I want to know the mass of 1 mole of phosphorus, I go to my periodic table and I see that it is 30.974. All right, and so I'm going to write that down, 30.974 grams per mole. And chlorine is, look it up on your periodic table, 35.453 grams per mole. And so you multiply those out. And if you do, you should get something like 61.948 grams per mole. And you should get something like 354.53 grams per mole here. So we add those up. And you should get 416.478 grams per mole. So the first step into answering any of these is to make sure that you get the right formula. You have to make sure this formula is right, because if you're off on any of these numbers, then you're going to be off in your final answer. So make sure you're paying attention to that. All right, and then this next one. Go to the next one. It says calculate the mass of 1 mole of calcium phosphate. And we're going to end with calcium phosphate. We're going to stay on calcium phosphate for a long time because some of our other calculations are going to involve using the molar mass here. So, but notice this says calculate the mass of 1 mole. Notice the other problem said calculate the molar mass. Mass of 1 mole, molar mass. They mean the same thing. The molar mass is equal to the mass of 1 mole. That's exactly what it means. So when we look at calcium phosphate, we don't see any prefixes in calcium phosphate. So we should know that we're dealing with an ionic compound. And we're not dealing with an acid, but even if we're dealing with an acid, we have to look at charges. The only one you do not look at charges is your molecules, and they have prefixes. There's no prefix here, there's no prefix here, so we know we have an ionic compound. So we find calcium on our periodic table, and it's 2+, and we find phosphate, and that is on our polyatomic ion sheet, and you can find that there, look it up. And it's 3-. We see that 2 plus -3 does not equal 0. So now we write 2. I'm sorry. We write 3. And we write 2. All right. So we rewrite this Ca3 PO4 2. And I chose this problem for a reason because some people are having some issues counting the number of atoms when we have it expressed this way. So if we want to calculate the molar mass of calcium phosphate, we have to know how many of each atom, well, what type of atoms we have, and then how many of each we have. So when you see this, you simply write calcium, phosphorus, and oxygen. These are the 3 things that we see in this compound. So you do not keep the phosphate together. You do not say PO4 is one thing. When you're calculating the molar mass, you separate everything. So how many calcium do we have? 3. How many phosphorus do we have? We have 2, because this phosphate is having 2 of those. It looks like this. And if you had calcium and you have 3 of these, so this is what this looks like. If you were to count 2 of these, you can see you have 1, 2 phosphorus. So we have 2. So the easier way is to take your 2 that's outside of the parentheses and just multiply it by your subscript. In this case, it's 1. So 1 times 2 is 2. If you look at your oxygen, it's 2 times 4, which is 8. Or you can look 4 plus 4 is 8. Either way, they work. I personally would not draw this picture every time I had this because it's way more work than I would like to do. So if we look at our periodic table, we can now find the molar mass of all of these. So if you go to your periodic table, you should see calcium is 40.078 grams per mole. You should see phosphorus is 30.974 grams per mole. And you should see oxygen is 15.999 grams per mole. So you just simply multiply those out. So let's do that real quick. 3 times 40.078, and you get 120.234 grams per mole. And if you got 30.974 times 2, that gives you 61.948 grams per mole. And then if you have 8 times 15.999, that gives you 127.992 grams per mole. All right, and so you simply add all this up, and you should get something like 310.174 grams per mole. And this is of calcium phosphate. Now parentheses is required. Without that parentheses, you're going to get the wrong count. Okay, so 100 or 310.174 grams per mole. So just to make things easy, not to take too much time in this video, I went ahead and used calcium phosphate for the rest of these calculations so that we don't have to calculate the molar mass of several different problems. So we're going to be using this molar mass in our other problems. So this next one says calculate the mass of 0.379 moles of calcium phosphate. Now you're free to pause this video and then see if you can get it on your own and then check it, or you can just follow along. But just simply watching without writing is going to do you really no good. You really need to participate along with the video. So what we're calculating is the mass. And what you should know is mass is the unit of mass is grams. All right. And here we have 0.379 moles. So if we're calculating the mass, that means we don't know the mass. So we have to find that. But we do know that we have 0.379 moles of calcium phosphate. And the nice thing about this is we already know the formula, we already know the molar mass, all of that, but we do not know the mass of 3.79 moles. So we're going to find that. Okay, so in order to do that, what we do is we take what's given. We can see 0.379. So let's use that, 0.379 moles of calcium phosphate. And it's very important that you write moles and calcium phosphate. And we're gonna try to find out where to go from here. Well, you should know if you're going from moles to mass, let's make sure we can see this. We're going from moles to mass, MOL, to grams. We can only get there by knowing the molar mass. All right, so we have to know the molar mass. So we're going to go from moles to mass by using the molar mass. The nice thing is we already know the molar mass. So let's go ahead and use this. So we have moles down here, and we know this has to be the case because moles has to cancel. So moles is in the numerator, moles is up here, moles must be down here. And anytime you're seeing the unit mole in one of these brackets until we get to a balanced chemical equation, you're going to use the number 1. Everything is related to 1 mole. Your molar mass is the mass of 1 mole. That's what we said, right? So if this is my molar mass, that's the mass of 1 mole. That means 310.174 grams is in 1 mole. So here's 1 mole. And what is 1 mole? 310.174 grams of calcium phosphate. And notice if I'm looking for grams, and I have grams in the top portion of my bracket, I know I'm finished. I don't have to do any more work. And so I simply take 310.174 and I multiply that by 0.379. And because I only have 1 in the bottom of the bracket, I don't need to divide unless you like to divide by 1, but you would get the same thing. You would get 117.56 grams of calcium phosphate. And I'm rounding this. It's actually 0.555946, but I'm just going to round that to 5.6. All right, and so that's our answer there. 117.56 grams of calcium phosphate. Now we asked, does that make sense? Well, is 0.379, is that greater than or less than 1? And we know that it is less than 1. All right, and actually it's a little over a third, right? Or almost a fourth rather. So anyway, we can see that it's much less than 1. And if we had 1 mole, we'd have 310 grams. We have less than 1 mole, and we have less than 310 grams. So our answer makes sense. All right, we go to the next one. Calculate the number of formula units in 117.56 grams of calcium phosphate. So when we look at formula units is the representative particle of an ionic compound, and calcium phosphate is an ionic compound. So if we're going to go from grams, we're going to go to moles, and then we're going to go to formula units. And on your worksheet that we had, this said particles, and one of the particles is a formula unit. But anytime you go from grams to moles, you're using molar mass. Anytime you're going from moles to atoms, formula units, molecules, you're going to be using 6.02 times 10 to the 23rd, which is Avogadro's number. All right, and so we're going to do that right now. So if we have 117.56 grams of calcium phosphate, all right, we're going to use now our molar mass of calcium phosphate, which we said earlier was 310.174. So 310.174 grams of calcium phosphate. And you notice that calcium phosphate and grams of calcium phosphate and grams of calcium phosphate. One is whatever's in the top bracket is going to be down here on this side of that bracket, always. And what does the grams equal? This mass equals what? The mass of 1 mole. So it equals 1 mole of calcium phosphate. But are we at formula units on our bracket? No, we're at moles. So we're right here on our map. We're right here. This is where we are on our map. We're at moles. So now we need to go to formula units. How do we get to formula units? We use Avogadro's number. So now if we have 1 mole of calcium, this is a no-brainer. If I know that these units are always the same, if I know this is the same as this, and I know this is the same as that, you notice I'm looking at the units. All right, they are the same. Grams of calcium phosphate, grams of calcium phosphate, moles of calcium phosphate, moles of calcium phosphate. And now I'm just going to simply take this to the next level. I'm going to say, okay, how many formula units are in calcium phosphate? Well, we're using what? Avogadro's number, which is 6.02 times 10 to the 23rd. Formula units of calcium phosphate. All right, and so now all we have to do is plug this in our calculator, and we see that we have 117.56 divided by 310.174. And then we can multiply that by Avogadro's number, 6.02. Make sure you know that's a 2. You should know that anyway. Times 6.02 times 10 to the 23rd. And you should get 2.28 times 10 to the 23rd formula units of Ca3PO42, or calcium phosphate. And so you ask yourself, well, does that make sense? Well, if I know 1 mole is 6.02 times 10 to the 23rd, and it takes 310 grams to get to 1 mole, and I only have 117 grams, the number of formula units should be less than 6.02 times 10 to the 23rd. And it is. It's 2.28 times 10 to the 23rd. So my answer does make sense. Okay. And so there's my answer there. All right. And then our last problem, and I've made all these very connected, in case you didn't know. We looked at the molar mass, then we found the mass of 0.379 moles. I used the same mass, and sure enough, we said that's 2.28 times 10 to the 23rd. But now we're going to calculate the mass of 2.28 times 10 to the 23rd formula units of calcium phosphate. And I bet you already know the answer to this. So, but we're gonna set up our bracket anyway. So we have calculate the mass. So we need to calculate the mass. We do not know the mass. So we're going to find what is the mass of calcium phosphate. When we know we have 2.28 times 10 to the 23rd formula units of calcium phosphate. All right, so here we're going to go from formula units, which is like particles, to moles. Notice moles is in every one of these maps, to grams or mass. All right, what do we need to go from formula units? Avogadro's number, which is 6.02 times 10 to the 23rd. What do we go from moles to grams? Molar mass. And we already know the molar mass of calcium phosphate. We calculated it way up here. Molar mass of calcium phosphate is way up here, or the mass of 1 mole. All right, so we have 2.28 times 10 to the 23rd formula units of calcium phosphate. We know we're going to use Avogadro's number now, so we're going to say 6.02 times 10 to the 23rd formula units of calcium phosphate is equal to 1 mole of calcium phosphate. And that 1 mole, notice we see 1 on every time we see mole, we're saying 1 is equal to the molar mass, which we said earlier was 310.174. Just say it, we calculated it. Grams of Ca3, PO4, 2. All right, and so with that, we simply plug in our values with our calculator. And so if you notice that you have two things, they're both times 10 to the 23rd, you can just take 2.28 divided by 6.02. You don't need to plug in that times 10 to the 23rd, especially when they're the same exponent. They're going to cancel. So you can either plug that in your calculator, or you can just take 2.28 and you divide that by 6.02 and then multiply that by 310.174, and you'll get 117.47 grams of calcium phosphate. And it didn't quite come out to be 117.56, but it's really close. And it's probably because I didn't use 6.023, and that's probably the difference there. I just used 6.02, so I rounded somewhere. But my answer is really close, and it would choose the right answer on a multiple choice test. So anyway, I hope that this really helped you out. And if you have any questions, please see me. But be preparing for that pop quiz. And I know you're going to do well. I'm very, very confident. Okay, well, thank you for watching. Please tell your friends. Have a good evening.